Hey there, welcome to another session on math problem solving, and here's today's problem. You have three squares of different lengths, 3, 4, and 7, stacked right next to each other. You have a line that cuts through all three squares, forming three different triangles. Blue is the triangle in smallest, red in the next one, and gray in it. Please do observe that the gray triangle doesn't connect the entire of the square, it's just part of it. How do you go about solving this problem? The question is to find the area of the shaded region. Okay, so if you've seen our videos before, productive struggle is a very important part of the process. So I would like you to stop this video here and try to solve this problem and then come back to see the solution. Okay, welcome back. I hope you were able to attempt the problem. So it's very, very important that you go through the phase of productive struggle. Extremely important, even if the solution is to be given. Because remember that math is not about just getting the answer. If I were to give you this problem and just give you an answer saying, hey, this is the answer of this problem, then I think the entire purpose of mathematical problem solving is lost. The real purpose of math is actually to learn the perspective of the problem. It's to learn the method of the problem, the process behind it. So it's extremely important that you learn how to approach this problem. Okay, the most efficient way of approaching this problem is to find the interconnectedness between the triangles and then be able to find out what is the one variable that you need to find out so that you can get the answer. So let's start with what the basic idea of the area of a triangle is, which is essentially the base times height. So for the blue triangle, I have the base of 3, I don't have its height, let me call it x. For the red triangle, I have its height to be 4, I don't have its base, let me call that y. For the gray triangle, I do have the base, though it's not mentioned. I should recognize, I should be able to deduce that the base, this particular length, is nothing but 3. Why? Because it's right next to a square which is 4, height of which is 4, and together this height and 4 should add up to 7, therefore making it 3. But I don't know what this is, so I'm going to call it z. Okay, now the area of a triangle is half times base times height. So for the blue triangle, it is going to be 3 times x. And I'm just going to keep the common half out. For the red triangle, it is going to be 4 times y. And for the gray triangle, it's going to be 3 times z. But of course, as you can see, I have multiple variables. I have x, y, and z here. So how do I simplify this? How do I make it easier? So I should be able to find the connection between each one of them. Now, how are x and y connected? If you notice it, x and y together make 4, which means y is nothing but 4 minus x. So let me go back to the previous one, is 4 minus x. So by putting it back here in this equation, I can substitute this and I would essentially get 3x plus 4 times 4 minus x, eliminating y. How is z connected to x? Now, to understand that, we need to realize that the gray, red, and blue triangle are all similar. If they're similar, then the ratios are in proportion. So the base of the blue triangle is 3 divided by its height, which is x. The base of the gray triangle is z, divided by its height, which is 3. So you can basically extrapolate here saying that z is 9 by x. So now we can substitute all that we have figured out so far and it becomes a mere fact of algebra. 3x plus y is 4 minus x, making it 16 minus 4x. and z is 9 by x, making it 27 by x. The whole thing multiplied by half. So in other words, it's nothing but 16 minus x plus 27 by x. This whole thing divided by 2 or multiplied by half. So now the only question comes about, like, what exactly is the value of x? How do I figure out what the value of x is? For that, you have to understand that the concept of similar triangles. So you have the blue triangle, which is similar, but if you add this shaded region to the blue triangle, then you have a larger triangle, which is also similar. Remember, for the larger triangle, the base is 7 and the height is 4. So applying the same logic of similar triangles, I can say 4 by 7, which is the height by the base for the larger triangle, is equal to x by 3. Therefore, x is nothing but 12 by 7. So substituting 12 by 7 in this, I can say it's 16 minus 12 by 7 plus it's 27 by x. So 27 divided by 12 by 7. The whole thing multiplied by half. Now we have reduced it from algebra to arithmetic. So you can see that there are common factors, so on and so forth. You can go ahead and try to solve this problem and arrive at the answer. Okay, so I think I'll leave it here because it's more arithmetic manipulation that's just eventually going to get you the answer. If you know the answer, if you can accurately find it in either a fractional or decimal form, please leave your answer in the comments for everybody else to actually see what the solution is or what the answer is. Now, I'm deliberately not giving you the answer here because I think my entire premise here is that answer is not important. It's the method. It's the fact that you can look at a problem like this and connect it out to one variable. Like, you can take the entire area that you want to find out and reduce it to one single variable. And you could do the same thing if you were to assume the area of the blue triangle to be A. Then red can be some version of A or some factor of A, and the gray one would be some other factor of A. And then you would have an algebraic equation of A plus KA plus, MA, something like that. So you'd have each one, the red one could be K times A and the gray one could be M times A. And you would just have a single variable connecting you to the answer. Now that's the beauty of math, because to solve this problem, all you need to do is to identify that one variable, which is either X or A, and be able to rewrite the individual parts in terms of that variable. And when you're able to do that, then you have essentially connected an unknown to a known value. And determining the known value would make the unknown also kind of demystified and get you the solution. I hope you enjoyed this video. If so, please do share, like, and subscribe. And I'll see you in the next one. Thank you.